Hello everyone. This video we're gonna finish chapter 3 review section. First one, section 3.1, simple rate of change of formulas. So in this section we are given a couple of formulas for the derivative. So first one is if the function is a constant function, then the derivative is 0. And the second one is f of x is x to the nth power, then the derivative is just the n multiplied by x to the n minus 1. And the next one is about a constant number c multiplied by a function g of x, where c is a constant number. So the derivative, we just keep the same c and take the derivative of the function g prime of x. And then for the summation and the subtraction, f of x plus g of x, then the derivative is just f prime of x plus g prime of x. And the similar for the subtraction. So, and the second box shows you 3 formulas. The first one is x to the 1 over nth power. It's just the nth root of x. And then the second one, we use this method, then we are gonna get this one. So, and this one is also equals to, so let me see. First, we can take the nth root and then take it to the m's power. So they're the same. And then the last one is 1 over x to the nth power is just x to the minus n. N can be any number as long as n is positive. So let's see an example, the last two. So the derivative of this one, first we are going to rewrite this function. So the first one is 1 over x to the 1/2 power. Then this is just x to the minus 1/2 power. So the derivative is just, let's see, minus 1/2 multiplied by x to the n minus 1. So it is minus 3/2. And then this one is just 1 over the denominator is just x to the 2/3 power. Then because 2/3 is in the denominator, so it's just the x to the minus 2/3 power. So the derivative g prime of x is just minus 2/3, then multiplied by x to the n minus 1, which is minus 5/3. And then, just wait a minute. Example 4. Okay, example 4, we're going to talk about this one. So first, let's rewrite it. This one equals to 3x squared divided by 2x, then minus 4x divided by 2x, plus 8 divided by 2x. So you can see the first term is just 3/2 x minus 2, then plus 4 over x. Then we take the derivative, it's just the f prime of x is just 2/3. Excuse me, 3/2. 3/2. Then this is a constant number, so derivative is just 0. And the derivative of this one is just plus 4 multiplied by minus x, because the 1 over x is just x to the minus 1's power. And the next one, let's see example 5. Example 5, we are given a function n of x. All right, just read the question by yourself. All right, this is the function n of x. The unit is million people, and this one is the number of Americans age 65, excuse me, or older, x years after 2000. So the first one, what is the projected number in 2030? So this one just says, what is the n of 30? And the answer is just 7 because 2030 means 30 years after 2000. So it's just 70.85 million people. And how quickly, the next one is about the derivative. So this one is, what is n prime of 30? Because it's the same year, 2030. So still, x is 30. So this one is, what is the n prime of 30? So for n prime of 30, we can use this instruction. The first, we just use y1. That is n of x. This is our y1. Then for the derivative, for example, what is the n prime of 30 if we are given the function n of x? So we use mass 8 minus 8. Then you can see minus 8. Then you have this one. So actually, we have the two different forms. It depends on your calculator. So this is the first type. You just see this is the y1, which is our function x input variable. 30 is actually just the input value. And if your calculator is like this one, then you can see this is the second form, dy1, the denominator dx, which is the input variable, and here that is the input value, which is 30. So you can see this is the result. All right. So then hit enter. Then you are gonna get the result, which is 1.509, and the unit, because this is the derivative, is output unit per input unit. Output unit is million people, input unit is just year, so million people per year. And then this part, calculate the percentage rate of change. Percentage rate of change, the formula is f prime of x and n prime of 30 divided by f of x, which is n of 30 times 100%. So this is the percentage rate of change. And this one, you can see the right side. This one is the derivative n prime of 30. So we use this answer, which is this one, divided by 1 of 30, so which is n of 30. Then because we have the 100%, so times 100%. This is you can see, this is 2.129. Then because this is the percentage rate of change, excuse me. So the unit is percent per input unit, so percent input unit is year, so percent per year. And then the next one, rate of change model. So rate of change model, you have to include the 4 parts. The first one, derivative equation, then output description with derivative units, and input description with units, and then the last part is an input data range. So this is a rate of change model. First, the n prime of x is just minus 0.00246 square plus, and the unit is output unit per input unit, so million people per year. And then this gives the rate of change, because this is the rate of change model, gives the rate of change in the number form, blah blah blah. And then input variable is x years after 2000, and the range is through 2050. So next, let's see 2 more examples in this section. This one and that one. So the derivative of this one, r prime of x, the first term is x to the e's power. E is just a constant number, so it's the same as x to the n's power. Derivative is just n multiplied by x to the n minus 1's power. So this time, n, the value of n is just e, so we just use e multiplied by x to the n minus 1, e minus 1's power. Then pi is a constant number, x cubed, derivative is 3x squared. Then we are done. And the last one, g of x. First, let's rewrite this equation. This term is just x to the 3/2 power, then minus 2/3 multiplied by 1 over square root of x. This is just x to the 3/2 power minus 2/3 multiplied by x to the 1. This term is just 1 over x to the 1/2 power. So it is just x to the minus 1/2 power. So let's take the derivative. G prime of x is just a 2/3, 3/2, x to the 3/2 minus 1, which is 1/2. Then minus 2/3. Then this one is minus 1/2 multiplied by x to the minus 3/2. So it's just 3. And this term plus 1/3 x to the minus 3/2. All right, next section, 3.2. 3.2 exponential logarithmic. Okay, so this one, the first formula is e to the x power. The derivative is just e to the x. And then the second one is b to the x. Derivative is natural log of b multiplied by b to the x power. So the second one is a more general formula, because if we are only given this one, then you can just plug in b as e, then you are gonna get e to the x power, the derivative is natural log of e multiplied by e to the x power. So this term is 1. So that's how we get e to the x power. It's just the e to the x, excuse me, e to the x power's derivative is just the e to the x power. And then for the function f of x is natural log of x, where x cannot be negative, then the derivative is just 1 over x. So let's see 2 examples. This one and that one. All right, for the first one, and this is about the optional parts. So that means this one will not be on the test, on the final exam, but this is also an important one. F of x equals to sine of x, then the derivative is cosine of x. And for the function cosine of x, the derivative is just the negative sine of x. And for this one, the first term, this is the first function minus the second function, so we have to take the derivative of the first one. 2 is a constant number, then derivative is just 1.5 to the x power, then multiply by natural log of 1.5. Then minus derivative of 3x is just 3. And the second one, g prime of t. So the first term is 4, because 4 multiplied by e to the t this is the constant number, so we keep the constant number c. That is 4, then multiply by e to the t's power. But the second one, because 3e squared is just a constant number, so derivative is 0, then we don't have the second term in the derivative. And then next, let's see this one. This one, f prime of x, the first term, 2 multiplied by natural log of x is just 2 over x. And then the next part, 2 to the x power is just 2 to the x power, then multiplied by natural log of 2. And the last term, 3 natural log of 2, is just a constant number, so derivative is 0. And let's see section 3.3. All right. All right, section 3.3 is the derivative for the function composition. So for example, if we are given f of t and t of x, and ask you what is the derivative of f of t of x, so this is the first form of the chain rule, df dx is just a df dt multiplied by dt dx. And to use the first form of the chain rule, first we have to find the derivative of each of the 2 given functions, then multiply them together. And the last step is to rewrite in terms of the single input variable. So let's see example 4. All right, let's do example 6 first, then go back to example 4. So example 6, we are given h of -1, g of -5, dh dx. This one, you can write it as h prime of -1. They're the same. And the other one is g prime of 5. They're the same. All right, so the first one, this is a composite function composition, g of h of -1. So this one is g. First, h of -1 is just 5. So g of 5, because this one is just 5. And then g of 5 is given directly 0.2. So this one is 0.2. And this one, dg dx. So this time we are given the value of x is just a -1. So by using the formula, it's dg dh dx. Because here we are given the value of x directly, that is just a -1. But here we are not given directly. You have to calculate it. That means, all right, now we are only given x equals to -1. But since in the denominator we are only the denominator is h, so that means here it must be the value of h. It cannot be the value of x. But because if you use this function, you can see if we are given the value of x, that is -1, then the corresponding h is just 5. So by using this one, we know the value when x is -1, the corresponding h is just 5. So that's how we got this one. And then this term dh dx, when x is -1, this is 3. And this one dg dh, h is 5, it's just a -1.5. So we multiply them together, that is -4.5. Example 4. All right, just read the question. And pause the video, try to do it. All right, so for this one, we are given two functions. The first one, A of V dollars represent the average cost to produce a student violin when we are produced. So the second one, V of t, is just the number. So the first one is the average cost. The second one is the number. And this one shows you in 2011, 10,000 violins are produced and the production is increasing by 100 per year. So all right, in this one you can see the input variable is just the t year. The value of t is given, that is 2011, and then the first function is v. So the output of the first function is v of t, and the output of the first function is actually the input of the second function. So v of t, they are the same. And the second one, after you plug in, the input is just v of t. Then we have a of v of t. The unit is dollars. So the input variable for the function a. For this function, a of v of t, the input variable is just t, so the input unit is just years. And then the output unit is a of v of t. A of something unit is just dollars, so this unit is just dollars. And the v of 2011, so we know v represents the number. So here, in year 2011, then we know this is the number of violins. So it's just 10,000. And the unit for V is just this one. So that's how we got this one. And the A of 10,000. So n of 10,000, that means when 10,000 violins are produced, the average cost, because A of something means the average cost when V is just the V violins. So here we know when V equals to 10,000, then the corresponding A of V is right here. 142.1, and the unit is just dollars. And the average cost, so this is talking about this part. And the next one, DADT. So this is for a function conversation. DADT, same. We are given the value of t is 2011. Then by using the first form of the chain rule, is dAdv multiplied by dv dt. So because we are given the value of t directly, here, this is similar to example 6. So here, because dv, v is in the denominator, that means we have to use the value of v instead of the value of t. But because when we are given the value of t is 2011, then the corresponding v value, v of 2011 is 10,000. So that's how we got this 10,000. So this one is given directly because the average cost is decreasing. Decreasing means negative. So the average cost is A. It's decreasing by, you can see, output unit per input unit. So this is A prime of 2011. So the derivative is just this one, because the decreasing must be negative. Then the unit is dollars per violin, so dollars per violin. And then similar dv dt is just 100 violins per year. And then you can see, because both of them, this one has a violin in the denominator, this one in the denominator, so this one can be cancelled. Then the only unit is just this one multiplied by 100, then we got then we get -15. The unit is dollars per year. Then the sentence of interpretation will be similar. So the next one, section 3.4. Three 3.4 right here. All right. So for section 3.4, right here. So 3.4 is about the rate of change of this is pretty similar to section 3.3, but just to give you more examples. So the same function f of x is g of h of x. So this one, it has an outside function and an inside function. Inside function is just h. Outside function is g. So for this one, this is the second form of the chain rule. F prime of x is g prime of h of x. That is the derivative of the outside function, then multiplied by the derivative of the inside function h prime of x. So the derivative of the outside multiplied by the derivative of the inside function. So let's see one example. Example 2. Example 2, you can see here, natural log of x cubed minus 5x squared. So this is a function computation. We have two functions, inside one and outside one. So the inside function is just, you can see this one in the parentheses. That is just we use the notation h of x is x cubed minus 5x squared. And the outside function is natural log of something. So g of h is just a natural log of h. The derivative of the outside function is just the natural log of h, is just 1 over h. And the other one, x cubed minus 5x squared, the derivative is just this one. So the last step, we have to multiply them together. So the derivative of the inside function, because the f prime of x is a function of x, that means the right side must be a function of x. We cannot have h inside. So this one is okay because no h there. Then we just plug it in, the derivative of the inside function. But for this one, the derivative of the outside function. For this one, 1 over x, we have h there. So we have to plug in h is this one. So we don't have h there. That is 1 over x cubed minus 5x squared. Let's see 3 more examples. F and g. So this one, 2 multiplied by natural log of square root of x. So this one, the inside function is the square root of x, which is x to the 1/2 power. The outside function is 2 multiplied by natural log of h. So we take the derivative. The inside one is just this one. So the derivative of the inside function is 1/2 multiplied by x to the 1/2 minus 1, which is x to the minus 1/2 power. Then the outside function is 2 natural log of something. So it's just 2 multiplied by 1 over square root of x. Then we can cancel this one. It's just 1. And x to the minus 1/2 is just 1 over x, square root of x. So we got 1 over x. All right. And similar for the next one, f of x, just this one. So we take the derivative. 0.5 is a constant number, so let's keep it. Then multiply by e to the this term. But this term is not a simple function. Then we have to take the derivative of this one. The derivative of this one is right here. That is minus 6x plus 2. Then example 7. So make sure you know how to solve for example 7. Example 7 is more complicated than last example I showed you. This one, it's a three functions. It's a function composition of 3 functions. So g of h of k of x. And for this one, the inside function is just, we use a k of x. That is just this one. That is minus 3x squared, blah, 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 blah. And then the second part is square root of the blue one. So square root of k is k to the 1/2 power. And the last part is e to the h's power. So e to the h's power. And then the derivative, we use this formula, g prime of h of kx multiplied by h prime of kx multiplied by k prime of x. Derivative of this term is just right here. Derivative of this term is this one, but we cannot use k, so just plug in k equals to this term. And the last term, e to the h power is just e to the h's power, but h is not this is not a function of h, so we have to use h of k is just a square root of k. But still, because this is not a function of k, so we have to plug in k is this one. Then we are done. And next part, example section 3.5. For section 3.5, this is about rate of change. This is a difference from last two sections. This time we're given, instead of a function composition, g of h of x. This is a, for example, g of x is a function composition, but h of x is actually a function multiplication. Pay attention to the difference. One is multiplication is a dot, function composition is a circle. So the formula is g prime of x multiplied by h of x plus g of x times h prime of x. So let's see one example. Let's see example 5. So first, let's do example 7 first. So example 7 is a function multiplication. So the first term, f of minus 1, is just this. The second row shows you when x is minus 1. F of minus 1 is just g of minus 1 times h of minus 1. G of minus 1 is given this one. G of minus 1 is this one. H of minus 1 is this one. So the answer is just minus 40. And the second one, f prime of x. F prime of x is just g prime of x multiplied by h of x plus g of x multiplied by h prime of x. So we plug, okay. And then for c, we plug in x is minus 1. G prime of minus 1 is this one. H of minus 1 is this one, minus 8. Plus g of x is just 5. H prime of x just minus 0.025. So the answer is minus 0.285. And then let's go back to example 5. Example 5, we are given the f of x. This is the percent, and the other function s of x is the many students, is the number of students. Gives the full-time enrollment in American public colleges and universities. Where x equals to 1 means fall 2000, x equals to 2 means fall 2001. So the first one, this is a model. So this is a model for the number of full-time students with blah, blah, blah. So we know this is a multiplication of the two functions. But because one is the percentage, the other is just the number of students. So g of x, after you multiply them together, we have to divide it by 100 because f of x is the percent. So you have to divide it by 100. Then just multiply them together. That is divided by 100 times 0.76 natural log of x plus 6.5. And the unit is just million students. Because just multiply them together, then this is a simple calculation. Then finish it, gives the number of full-time students, blah, 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 blah. And then this part shows you how many students, all right. So you can see this part, how many students had financial aid. So this one is a function multiplication, not a function composition. So you can see here, y1 is just the f of x. Then we have the y2 is actually s of x. So we generate a y3. So for the function composition, if it is a function composition, then it is y1 of y2. But this one is a multiplication, so instead of using parentheses, we use the multiplication. And then the answer for question B is just the y3 of 11, then this is y3 of 11. So the next question is, what is the y prime of 11? What is g prime of 11? So, because how quickly, that means the derivative. So, what is g prime of 11, where g of x is the new function? So, for this one, g of x is actually our y3. So, for y3 of g prime of 11, we use -8. So, you can see here. If this is the first time, this is the second time. X is 11, so you can see this is g prime of 11. Then, all right, last section 3.6 in chapter 3. 3.6 gives you more examples. So, for example, example 2. Example 2. This is the first function. This is the second function. So, for this one, first function and the second function we can rewrite it as square root of x is just the x to the 1/2 power. So this one is just a x cubed minus 5x squared to the 1/2 power. So the first derivative g prime of x is just the e to the 2x. 2x is not a simple function. Excuse me. Um, 2x is not a simple function, so we have to take the derivative of 2x. So like last example, we showed you e to the pi x. The derivative is just e to the pi x multiplied by the derivative of pi x, which is pi. So this one is 2 multiplied by e to the 2x. Then this term, derivative is just 1/2 multiplied by this term minus to the minus 1/2 power. But because this is a function conversation, then we have multiplied by the derivative of the inside function. This is the derivative of the yellow part. And then we just plug in g prime of x is this one, h of x is this one. So we got this one. This is the derivative. And then let's see example. All right, so for example C is similar. Let's see example F. So example F, this is the first function and this is the second function. So the derivative of the first function is just 2 multiplied by 5 to the x power, then multiplied by natural log of 5, multiplied by the second function, plus the first function, multiplied by the derivative of the second function, which is 1/x. All right, that's all for chapter 3. So next video, we're going to finish the final exam review, chapter 4. All right, thanks for watching.